Alright, we are continuing to look at our variances and doing variance analysis from Chapter 7. If you had looked at the other problem, we focused on direct material and direct labor variances. In a problem in front of us, we're just looking at overhead. You can go ahead and take a look, if you would like, at the problem. This is what we're going to be working, and we'll kind of have the same setup as we had before, wherein we'll have formulas that will help us calculate our overhead variances. The approach we're taking here is called the four-step approach, or the four-prong approach to labor or overhead variances. What we're going to do is calculate the price and the quantity variance for both variable overhead and fixed overhead. So take a second to read the problem and we'll jump into it. I've copied over the pertinent data and I've got our formulas up here. You'll notice it's a little bit different than we had for direct labor and direct materials. We're going to start off with actual variable overhead to come up with our variable overhead spending variance, and then we're going to subtract the standard price times the actual quantity, and that will give us a variable overhead spending variance. A variable overhead efficiency variance can be calculated by taking the standard price times the actual quantity minus the standard price times the standard quantity. So a little bit different methodology here, but if you just follow the formulas, you should be okay. Let's go ahead and take a look and get our data set up here. First thing we're going to plug in is our actual variable overhead, and that's given to us in the problem. It says actual variable overhead $26,325. I'm just going to plug that number right in here. $26,325. To find our standard price for variable overhead per unit, we're going to have to do a little bit of math. The problem tells us our budgeted variable overhead costs are $315,000. We'll divide that by 70,000 direct labor hours. So 315,000 divided by 70,000 gives me a per unit amount of $4.50. The actual quantity incurred, standard times allowed for March production, were 5,980 direct labor hours and 290 machine hours. That's the standard. It tells us we actually incurred 5,900 direct labor hours. So that's the number we're going to go with, the actual amount, 5,900. So we multiply 5,900 times 450, and we get 26,550. And again, we're going to take that and subtract what actually occurred, and we get 225. So we will consider that a favorable variance. The standard that we calculated was actually more than what happened in real life. So when that happens, that's a favorable variance. So let's jump down to the second part, the variable overhead efficiency variance. We'll use our standard from above, $4.50. Our actual quantity, same as above, 5,900, for a total of 26,550 when we multiply those together. Again, we'll take our standard price per unit, $4.50. Don't let it round it off on you. And our standard quantity in this case was 5,980, and that information came straight from the problem. No math involved there. So we'll multiply that out. 450 times 5,980, and we get 26,910. So once again, we'll subtract standard from what actually occurred, and we get a $360 favorable variance. And again, we could add those two together, and that would give us our total variable overhead variance. So that's the calculation. Again, you can just keep that same setup, plug your numbers in, and you should be okay with that. Fixed overhead variances, we have a little bit different methodology. Again, you can't just copy the variable over to the fixed. We're going to take actual fixed overhead minus our budgeted fixed overhead, and that gives us our spending variance for fixed overhead. To get the volume variance, we look at our budgeted fixed overhead and subtract that from the standard price per unit times standard quantity. So again, we just start plugging in our numbers here. Nothing too fancy or tricky about any of this. It says in our problem, actual fixed overhead was $11,400. $11,400. budgeted fixed overhead, it doesn't give us a monthly amount, it gives us a yearly amount. Kemp will apply budgeted fixed overhead of $140,000 for the year. So we're going to take that $140,400 and divide it by 12. So we get $11,700. We're just going to take that and subtract it from $11,400 and we get a $300 favorable variance. Our budget was $11,700. The actual ended up being $300 less. It's going to be favorable. Let's go ahead and plug in our budgeted fixed amount for the volume variance, $11,700, and we'll take an SP and we'll calculate that. We need a per unit amount. It says budgeted fixed overhead was $140,400 on the basis of 3,900 budgeted machine hours. So equal $140,400 divided by 3,900. We get a standard price per machine hour of $36. Standard quantity, to get that straight from the problem, it tells us standard times allowed for March were 290 machine hours. So 290. We'll multiply these out. 36 times 290 equals 10,440. We'll take that, that's the standard, subtract it from the budget, and we get a negative 1,260, which we'll label unfavorable. So we could also do the journal entries here. We're not actually going to require that for the problems we're working, so we're not getting into that. But that's basically the idea. And again, I've set this up on Blackboard and given you guys a template to work off of. If you download that, all these formulas are laid out for you. You can just plug your numbers in and you should be good to go. If you have questions about how to make that happen or anything about variances, what they mean or what they stand for, let me know and we'll try to get those answered.